I am on page 212 in the margin. This is a 21st century skill, and this is a granddaddy of a problem. I'll just tell you up front, this one's a tough one. It's a good one, but it's going to involve a lot of steps. So if you're tired right now, I would put this video off until you're rested. And it may be better to just watch me do this one and then watch it again and do it with me, because there is a lot here to keep up with. Okay, if you want to pause the video and draw the graph, you can do that in the table. I have added a little bit to the table, and I'm going to add a little bit to the graph when we get there, but feel free to pause the video if you want. The story that goes with this problem. Yesterday, Max spent 1 hour bowling and burned about 224 calories. Today, Max will either swim or jump rope. And I didn't put that. This is the jump rope. And this one is spent swimming. It's in the table. The total number of calories burned during exercise for yesterday and today will depend on the amount of time Max spends swimming or jumping rope, as shown in the table and the graph. So in the table, this is hours spent swimming today, and then total calories burned for yesterday and today. So if he doesn't swim at all today, he still has 224 calories that he burned yesterday. If he swims half an hour today, he will have burned a total of 447 calories. And if he spends 1 hour swimming today, he will have burned a total of 670 calories. Now, I want to show you how to convert this time to minutes, just for the record. So 0 hours would be 0 minutes. A half an hour is 0.5 times 60, or 30 minutes. And 1 hour is, of course, 60 minutes. So if you needed to, you could put this time in minutes. They're showing me fractions of an hour. All right. So if you look over here at this graph, down here where it's got time and hours, let's make those comparisons here too. We know that in terms of minutes, this is hours, this is minutes, but they're equal data points. A whole hour is 60 minutes. 3/4 of an hour is 45 minutes, and then 1/4 of an hour is 15 minutes. So sometimes you will need to convert them back and forth. We don't have to in this case, but it's a good time to show you that you might have to sometimes. Okay, on this graph, let's go ahead and put a data point on here. Remember, if he spends 0 hours jumping rope, he still has the credit for yesterday's bowling. So this is at 0,224. And then they give us one more data point for this graph at 0.25. We're up here at 410. So at 0.25 hours, or 15 minutes, he has burned 410 calories jumping rope. And they go ahead and connect those two dots to make the function graph. And it is linear. It does not meet the 0, 0 criteria because he has that 224 calories that he's carrying over from yesterday. Okay, so we need to compare these graphs in order to answer some questions that I'll read in just a minute. But the first thing I'm going to do on this table, I need to find the slope. So I'm going to pick 2 points. I do not want to use the y-intercept. I want to use the 2 points that have actual values for the points. So I'm going to use the slope formula, and I will say that slope is y sub 2, I'll use the 670, minus the 447, over x sub 2 minus x sub 1. So I can tell you that on the bottom I have half an hour, and I believe it's 176 on top, but let me be sure. No, it's not. Where am I getting? Oh, I did this problem before. It's 223. And then you divide that by 0.5 and you get 446. So the 446 is the slope for this problem. If you want to write the equation, you would write it this way. Calories burned equal 446 times the number of hours plus yesterday's calories. Okay, now I'm going to make a copy of this because I'm going to use it again in just a minute. So calories, that's the dependent variable, is 446 times x hours plus yesterday's time is 224. That is the function for swimming. Okay, let's get the function for jumping rope. And here's where I'm going to use that same formula, except the slope is going to change. We have to figure out what that slope is. We know yesterday's calories. We know that hours is the x variable, calories is the y variable. So we need to know slope. Now, again, I don't want to use the y-intercept to get slope here. I want to do something else. I'm going to use a unit rate to get my slope. But we have to be very, very careful. This is not 410 calories starting at 0. This is, in other words, you don't burn 410 calories jumping rope for 15 minutes. I wish you did, but you don't, because we didn't start at 0 hours. We didn't start at 0, 0. So what we have to do first is subtract out. We have to say 410 minus yesterday's calories. This is where I think I'm getting the 176. 410 minus yesterday's calories was 186. So 186 calories were burned in 15 minutes. Okay, that's very important. You're not saying 410 calories in 15 minutes because you started way up here on the y-axis. You have to take out what you gained yesterday or what you got yesterday. So this is what we want to use in our unit rate. We are saying that he could burn 186 calories in 25 hundredths of an hour, or in 15 minutes. So let's see what he could burn in a whole hour. Okay, so 186 times 100, not times 100, times a 1 is 186. And 186 divided by 0.25 is 744. So that's 744 calories per hour jumping rope. Now, I can already tell you that he's going to burn more calories per hour jumping rope than he is swimming. He's going to burn 744 calories per hour jumping rope. Okay, so once you get those nailed down, let's take a look at the questions. Max wants to burn a total of at least 400 calories for yesterday and today. So let me try to block everything out of our field of view except this. He wants the total of yesterday and today to be greater than or equal to 400. All right. So his yesterday calories and his today calories need to be at least, at very minimum, 400. So yesterday, how many did he burn? He burned 224. Plus today, that's the variable. That's what we're trying to decide on. But I know if he does it swimming, he's going to do 446 for every hour that he swims. So I'm going to solve this inequality by bringing the 224 over. We get 446x is greater than or equal to 400 minus 224 is 176, and divide by 446, and it's going to be ugly, but don't panic, we're okay. Divided by 446 is, I'm going to round it to 0.39. And remember, x is hours, so he has to spend more, well, let's say at least 39 hundredths of an hour. And if you multiply that by 60 minutes, you get 23.4. So he would have to swim at least 24 minutes, we'll say, if we round it. Well, technically it rounds to 23. I'm going to say about 23 minutes. In order to burn those calories swimming. So you could answer this in a fraction of an hour, 0.39. We know that 0.5 is a half an hour, so 0.39 would be just a little less than that, or about 23 minutes, 23 to 24 minutes. So that's how you calculate the number of minutes, or the fraction of an hour, of swimming. Now, let's do it again. Remember, he wants to burn at least 400 calories yesterday plus today. We want it to hit at least 400 calories. And yesterday was 224. Today If he chooses to jump rope, that was what, 744x. So minus 224. $744x needs to be bigger than or at bare minimum equal to 176. Divide by 744. This will give you your fraction of an hour. So the fraction of an hour needs to be at least 0.24. That's rounded, of an hour, so almost a half an hour. Or if you multiply that times 60 minutes, it's going to be about 14 minutes. Of jumping rope. So to burn those calories, he can jump rope for 14 minutes, or he can swim for 23 minutes, and he will make that goal of 400 calories. This is not an easy problem. This is one that you really, really have to think about, and it involves that conversion of time and all sorts of funky things. But it's a good one. If you understand that one, you can do any of these that you run across, I truly believe.